My name is Ann Nolan. I'm a professor in the Department of Geography at the University of Nevada, Reno. My research focuses on snow and glaciers within our changing climate system. Well, I see that as one of the most important effects of my lifetime since I was born in the late 50s. And I'm a skier, and I have seen the snowpacks melting earlier, falling later, just a shorter snow season all around, especially in the western United States. And more recently, I've been looking at interactions between snow and forests and wildfire. So climate change is a really important part of the work that my students and I are doing. Lately, we've been measuring snowpack in burned areas in the Sierra Nevada, particularly in the Caldor fire, which was really unusual. It had a really large percentage of high burn severity. And then a second area of research has been in the boreal forest of Alaska. Now, the boreal forest is interesting because it actually covers the biggest land area of any ecosystem on our planet. And boreal means north, and so we're talking about all these regions in the Arctic and subarctic where you have forests of black spruce and similar types of trees. And our work has been looking at how those fires change the reflectivity of the landscape and of the snowpack itself. And so we can see that the landscape reflectivity increases after fire when there's snow on the landscape because there's no more dark forest. From the atmosphere looking down, like if you're a satellite looking down, you'd see the landscape would look a lot brighter. So you'd think, oh, that's reflecting away more solar energy. Maybe our planet's going to get brighter in these areas that have burned. But when we look specifically at the snow, we can see the snow itself is darker because of all the black stuff that's come off of the trees, and the snow itself melts off earlier. So we're looking at that balance between landscape albedo, or albedo is the word for reflectivity of snow, so that paradox of the landscape albedo becoming brighter and the snow albedo, its reflectivity, becoming darker and the snow melting off earlier. We see a much drier November than we used to see. We see more midwinter melt events, and these are particularly amplified during times when we have a lot of dry spells and when we have fires. Each one of these colored dots on the map represents one of these locations where we measure snowpack. Now, if we zoom in on a site, we can see this area in the Sierra Nevada here. Now, if we zoom in a little bit further, we can see the CSS lab. That's the Central Sierra Snow Lab. Nearly 93% of those stations over the last several decades have shown decreasing snowpack. Subsequent to the snowmelt, we see changes in the watershed hydrology. So the watershed is where, that's where our water comes from in the mountains, right? So we have all of those streams coming together to form a network. And up in the mountain areas is where we see these big changes. So down here in our communities, we're also seeing less stream flow, later spring, what we call the freshet, the earlier pulse of stream flow from snowmelt, and just an overall drying in our mountain regions. Now, this map from the EPA, it's a map of climate indicators for snowpack. We always look at April 1st because that's usually when we have the most amount of snow at any one of these sites. Anywhere you see a red dot is where the snowpack has declined over this period from 1955 to 2022. Anywhere there's a blue dot, that's where it's seen an increase. And you can see a lot of big red dots and a few smaller blue dots. The average decrease has been about 23%. Last year, our snowfall was at or far above average in most places across the western United States. And in the Sierra Nevada, it was just a record year, really epic snowfall. So people were saying, oh yeah, we're no more climate change, we've got so much snow. 2023 comes along, and now we're into 2024, and we've got significantly lower than average snow, and this is a lot more like the years that we saw preceding 2023. Now, I've pulled up a graph that shows this year's snowpack at the CSSL, the Central Sierra Snow Lab. And what you see here, this black line, represents the snowpack this year, right? And so here we are on February 2nd. This is today. You can see we're well below the green line. CSSL only has about 60% of that snowpack that we would normally have. Now I want to point out this last year, this was from 2023, this sort of brown, orangey brown line up here. And notice it went up to the absolute maximum. This was the most they've ever had in this period of April. So it really pushed the maximum up beyond whatever they had seen in the past. So this year is a low snow year, and I would anticipate probably an earlier snowmelt and maybe a more challenging fire season for this coming summer. You know, I think the best way to explain this complex topic to a wide variety of people, of community members, of scientifically literate public, of decision makers, members of Congress, and even members of the scientific community who aren't necessarily specialists, is to talk about it in ways where we're not using jargon. If I say words like climate change, that might mean something to one person versus another. But if I say something like earlier snowmelt or extreme drought, that has perhaps a more specific meaning that is more relevant to the group that I'm talking to. The other thing I think is really important is to talk about this complex subject. Just practice talking about it and talk about it with as many different people as you can, because we want as many people in our communities and decision makers to understand the challenges and as well as the details that are important in climate change. Because really, we don't want to make changes that are going to be painful and difficult, right? We want to make changes because they're easy and the right thing to do. And that is how we do that through policy and collective action. So for instance, when there was the ozone hole, countries came together through the Montreal Protocol and said, you know, we can do something about it. They agreed to this protocol, they reduced CFCs, and now the ozone hole is significantly smaller. So absolutely we can do this if we have leadership and collective action at the local, regional, and national levels and global levels. I've talked about snow today and how it's important in water and how it's important in our planet and part of climate, but it's important in a lot of ways. Snow is kind of the moisture subsidy that helps feed our forests and ecosystems from the spring into the summer, and it plays a really important role in how things grow. It plays an important role in agriculture. So if we think about all of the ways in which snow as a form of water and as important in our ecosystems and our communities, we can really see the linkages between these, and so we can start to act on those and really understand the importance of all of these components together.